And I'm going to share screen. I'm going to share screens in different ways. So first of all, sorry. What did I do? Hold on just a moment. Actually, I was going to bring up the textbook, but we seem to be having a problem here. Let's see. Okay. All right. Let's try this again. So let me share my screen. So here's the textbook, the e-text. So we're talking about long run economic growth, and I really want to talk about 6.1, the sources of economic growth and implications for the future. I'll bring something else up as well. We are not going to talk about the long run growth model, the Solow model. It gets to the same conclusions that we can talk about from the section 6.1, just looking at the numbers and looking at the actual economy. This is the theory behind that. As I said, this is what Robert Solow won the Nobel Prize for, or part of what he won the Nobel Prize for in economics. So sidebar is his son, John Solow was faculty member at University of Iowa when I was at University of Iowa doing my PhD, and we had our first children about the same time. Robert Solow, the Solow model Solow, would come to Iowa City regularly to see his grandbaby, along with his wife, who's also an economist. And so he would kind of park in an office, and we could, anybody could pop in and talk with him, etc. So that was kind of cool. Yeah, really, he's a really nice guy. So we're not going to talk about that. And then endogenous growth theory is a newer extension of the Solow growth model. And I'm going to talk through some of that in terms of the material from 6.1 briefly. And then we can talk about this last section as well in terms of what we talk about in section 6.1. And so what things can be used to increase productivity. Ultimately, at the end of the day, that's the really short version of chapter 6, that changes in productivity are the key to increasing living standards in the long run. Okay, that's the key. That's the bottom line. All right, so I am going to share. I'm going to do a different share. Okay. Let me bring that over. Well, actually, let me keep it over here. Whoops, things probably just went crazy on your screen for a moment there. I was moving things around. All right, so long run growth in the economy. So here's an aside. You don't see this picture isn't in this chapter, but if we have time on this axis, we have real GDP on this axis, and we think about long run growth. We're talking about, generally, we talk about long run growth of real GDP. So over time, real GDP, if we graph the data, it looks something maybe like that, right? So there are ups and downs in real GDP over time. So most of the time, do a different color, right? most of the time, the trend, right, is up, right? So here's the long run trend for real GDP over time. So this is like 2020 and oh, this is 1946 or whatever. We could use whatever years we want. But the point is, it's a time series. It's the plotting the actual data, right? So the blue line is the actual real GDP. So sometimes it's above the trend growth, sometimes it's below. We call those times when it's below, but a business cycle recessions, time when it's above, business cycle expansions, right? That's the material we're going to get into in chapters 8 and 9. So up to this point, we've really been talking about the long run model. So what determines this? That's the question, right? This long run trend, right? So there's two topics basically in macroeconomics: growth and business cycles. Like that's it. That's the course in a nutshell. So everything else is details around that. So the question is, can you do anything? Can we do anything, right, to cause this trend to go, let's say, up like that, rather than the growth sort of trend that it's on or not? What are the things that affect how that goes? If we took a really long run view and we started at like time 0, right? So we could even go BC if we wanted to, through 2021. And we had some measure of output like real GDP, real output in the sort of in the world economy. It would look like this, and then it would look like that, sort of a hockey stick. Sometimes it's called a hockey stick graph, right? So for for centuries, not much change in economic activity. I mean, economists have gone back and actually tried to calculate what output looked like from different records, from back from the Romans, back from the Greeks, etc. Mainly from the Romans, probably in that case, but then in going throughout that period. So what would have been the reason for this exponential growth at some point in time, do you think? And I'm using this to kind of motivate what we'll talk about here in a second. So what was the catalyst, do you think, for real output taking off? Yeah.
So I can give you two answers. I can give you the direct one, and I can give you the broad answer that's always correct. Which one do you want me to give you?
Yeah, give me the one that's always correct first, because I'm anticipating that's what you're going to tell me. But go ahead.
Market forces.
Oh, no, that wasn't what. Okay, it's the other one. It's the other one that I was expecting
The
you to tell me.
Industrial Revolution.
Yes, that's the one I was expecting to tell me. That's correct. That's correct. All right. Now the question is whether the Industrial Revolution came about because of market forces or not. We don't need to get into that discussion right now, that debate. But yeah. So what was in code? So what kinds of things come with the Industrial Revolution? Steam engine, right? To begin with, and we get railroads, we get then we get automobiles, etc. Right? So there's a change in capital. There's a change in technology that's going on. We also get, education, broader education, literacy, higher literacy rates, all that stuff. And things just take off, right? Exponential growth. So over the last 70 years in the US, about 3% growth overall in real GDP. It's we'll come back. I'll come back and say something about it's real GDP per capita that we really care about. So this is really real output per person. I mean, the actual real output would look like that too, but real output per person is actually doing this kind of thing. And so it's changes in productivity of workers, in particular, that leads to, from an economic standpoint, leads to that kind of big increase in real output per person. Why do we care about real output per person? Because for economists, anyway, or at least as a starting point, we don't have to stop there, but as a starting point, that is a measure of the standard of living, at least in a material sense. So we, as most economists generally think about standard of living as being tied up with output, real output, and growth of real output and real output per person in particular in the economy. Now, there's work by some economists that look at that and look at well-being, look at happiness, look at other things, which aren't necessarily directly tied to real GDP, and that's fine. That's no worries on that. But this is going to be our starting point, and it sort of serves as the foundation for the economic theory. Now, we'll see over time, over the next 20, 30, 40, 50 years, whether that continues to be the case. If issues of climate change become even bigger and even more serious and etc. So the thinking on this maybe will change, maybe not. But the question always is, well, what do changes in technology do? So if we were back in so an interesting point about this, if we were back in the 1970s, I'm not a climate denier at all. I'm very concerned about the whole issue. But I will point out that back in the 70s, when I was early 70s, I was in junior high. Big issues about pollution and the view that greenhouse gases would just warm up the earth, that we would all, and it just may be that it took longer than we thought, but that was going to happen soon. Like there were a lot of doomsday predictions at the time. What happens in those kinds of situations is that market forces actually, Calvin was talking about this before you got on Tanisha, but come into play and change technologies, new technologies come about that change the game a bit. Now, so that's a real question. That's a wild card, is will new technologies come about to reduce greenhouse gases, etc. It's not happening somewhat in terms of battery technology and electric cars. And you've seen in the last year, many of the major car companies making pledges to go all electric in the next 10 to 20 years. But it also takes energy to make energy, to make electricity as well. So it's not like a free ride. It's not like a free ride there. But there are a lot of things that are tied to higher real GDP. If you look at that across the world and across time, higher generally longer lives, fewer medical issues, depression, etc. More stability generally. There are a lot of positive things that come from higher levels of real GDP. Although that's not the only thing, but anyway, that's the reason for focusing on that. So what do we have back from chapter 3? What is real GDP? How is it determined? There we have this production function, that's the basis of how we think about real GDP and what causes changes in real GDP. And there are 3 things, right? Labor, capital, and total factor productivity. Right? And total factor productivity is something that affects both the productivity of both capital and labor together. Right? So if A increases, then Y is going to increase no matter what the level of capital and labor are. So things that shift the production function. All right. So we can do this in terms of, well, if we take natural logs of both sides of this, this is just a little math, right? Then one of the reasons for learning about natural logs and using natural logs in economics is because we can think about elasticities and we can think about percent changes. So we have the, this is all right. So we can then talk about the log of A plus 0.3 times the log of capital plus 0.7 times the log of n. So we can think about this then, right? In terms of these are really elasticities. If we think about this in terms of calculus, as we take the partial of the ln of y with respect to one of these are the partials of logs are essentially percent changes, right? So we can actually we can estimate this. It's not an exact thing, but we can do it in percent changes. Not percent change in y, not ln of y, plus 0.3 times the percent change in k plus 0.7. So math involved in that, but this is what we're interested in, right? So the growth of real GDP, right? The percent change in y is made up of changes in productivity, changes in the capital stock, changes in employment. So what the Congressional Budget Office and others do in terms of this notion of growth accounting, right, is they try and estimate what are the impacts of these different factors on growth. So what are we expecting in terms of the changes in each one of these components? Okay, and if we can figure that out, then we can get estimates of what we expect the growth of real GDP to be. So let me bring up another sorry. So I think this one will have it. See what's here. So in class, I would share Congressional Budget Office, which is the group that really looks at this, their publication, and what they're interested in. It's really a budget outlook, budget deficit outlook, but they have to make assumptions about long run growth. Sorry, I'm scrolling through here. I may not have the right one. This is a newer one, but it may not be exactly what I'm looking for.
Dr. Simpkins?
Mm-hmm.
One question I did want to ask, historically, how accurate have the Congressional Budget Office's economic forecasts been?
I would say pretty good, but
Okay.
things change, right? So this March, I'm looking at a March update on there. I'm going to go back to the January one, but so they have the values for growth of GDP and labor force participation rate, etc. Growth of productivity. These are all things that we want to look at, but there is a very specific table that they always have, but it may not be in this one. Sorry, I don't have this. I didn't have this up and ready to roll. I'll come back to this though, because I do want to. There's a graph in here that I do want to show. Okay. Sorry, okay, so I need to, I really do want to, you have a similar table in the book, but I want to bring up the current one. So this one from February. Okay, so the budget and economic outlook 2021 to 2031. So the answer to, let me just get this table up that I want. That's directly related to the equation we were just looking at. There we go. All right, so let me share this screen, and then we'll look at a couple of different things with this. So all right, so this is the Congressional Budget Office, their economic outlook. So 2021, 2031, they do this, they update this every year, and sometimes within the year. So this is from February. So let me come back to your question, Calvin, to how good are their forecasts, right? They use econometric models, just like the Federal Reserve uses econometric models. Private firms use these to try and predict what's going to happen in the economy over the short run, over the next month, 2 months, 6 months, and also to try and predict what's going to happen over the next decade, right? So this is a lot like meteorology, right? So weather forecasters can do pretty well at forecasting what's going to happen over the next 48 hours in terms of the forecast. Sometimes they're wrong even then, but they can do pretty good job with that, pretty accurate. When it comes out to forecasting the weather a week from now or 2 weeks from now, not as much. Right, so everything's relative is my point about that. How good are their forecasts? They're as good as they can be. I'll just say it that way, right? So do they change over time? Absolutely, just like weather forecasts do. There's that model underlying those weather forecasts in the same kind of way. So here's their forecasts. For example, this is the line, the projected line, 2021, 2031 for real potential GDP growth. That's what we're talking about when we talk about a long run growth. And here's the actual real GDP growth. So they're expecting, for example, real GDP growth to over it looks like maybe over 2021 roughly here to be, I don't know, maybe 4%, 5%, could even be higher this year, the actual real GDP. So growing faster than the long run average. We've been below potential for a while. Those are the business cycles, right? Those shaded areas are business cycles. So they're showing a strong, robust response post-COVID here, but we're interested in this orange line. What's happening to this orange line? And this is in growth rates rather than the actual level of real GDP. So I don't know. So you can see it's between 2 and 3% here. We'll get to the actual numbers in just a second. There's the output gap. That's the difference between the black and the orange line here. But it's really this. Not this one, sorry. It's really this table that we're interested in, right? So these are the different parts of trying to project real GDP, potential real GDP, right? The equation we were just talking about in terms of A, K, and N, right? So we're going to look down actually to this part right in here, this middle part, right in here. We'll come back. I'll come back and talk about this top part. It's something that goes beyond what's well, no, it's actually in this chapter as well. All right. So Here you have different time periods. So for our purposes, I mean, we can look at the individual time periods, but if we look at the last 70 years, right, what's been the general growth of real potential GDP? About 3%, right? So it depends how you bit overall, the non-farm business sector. It depends, and we can do it in terms of the individual components. 3.3, right around 3%. Okay. So what's the projection over the next decade? That's the real question. And you can see that we haven't been at 3% for some time. Back here, 1991, 2001, that decade was the last time we saw for over a period of 5 to 10 years, a real GDP growth at 3% or higher. And it was between 3 and 4% between 1950 and 2000 for about 50 years. And it has slowed down. So the question is, why is it slowed down? And what's the projection going forward? Well, the projection going forward is to be about 2.1%. So we're going to look at this column right here, right? This column right in here. And, or actually, sorry, let's look up here. Sorry, well, I'll explain that column. All right, let's look at this column and this column right in here. Been about 3%, forecast to be about 2%. Well, what's the big reason, right? Over the last 70 years, potential hours worked, that's the N in that percent change equation that we just had up on the screen in the growth accounting. Now it's 0.3, down a percentage point in the projection for potential hours worked. Capital, 3.4% growth, last 70 years, a little lower now. So the question is, why is that? And then total factor productivity, that's the A in our model, right? A little bit lower, not huge, but a little bit lower, right? So in the solo growth model, or in our model, we don't measure A directly in that production function. We get A as essentially as a residual, right? After we figured everything else out. So Y equals A times K to the 0.3, N to the 0.7. We have data for K, we have data for N, we have data for Y. We figure out what A is after we figure out those other things. We don't have a direct measure for A. So that's actually one of the things from the solo growth model, and one of the things that Solo was looking at the time, that it was just what's called A is just exogenous. It just happens, right? It's based on all these other things. We don't have a theory for what drives A over time. It's what's left after you've explained what you can from capital growth and growth in the potential hours worked. And then you look at what was the growth in real GDP, it's what was left. So it's a residual, right? So newer theories, endogenous growth theory, try to come up with theories about what actually causes changes in A over time, right? But Solo didn't have an answer for that, right? At the time, but came up with this idea of that's what it means, total factor productivity, and using this Cobb-Douglas production function, et cetera, because in the way that we just wrote it out, and I'll come back to that again, it's actually a regression equation, right? We can estimate those parameters. We can estimate the 0.7 and the 0.3. That's where it comes from the actual data, right? And the A is just a constant in that regression equation, and from econometrics. So that's where it comes from. Those numbers don't just kind of fall out of the sky. They actually come from estimating those equations using real data. So why the slowdown, right? Here's 3.4, 2.1. It's over a percentage point change in terms of the forecasted future growth. Well, labor has a big part to do that. Well, why would you expect that to be the case, right? Potential hours worked comes from two different things: number of workers and the labor force participation rate, right? So what's happening demographically in the US and around the world for that matter, right?
The labor force is aging.
Yeah, we're aging out, right? So there are just fewer people in terms of growth rates. There are fewer people contributing behind me right now, let's say. In other words, all of you, relative to how many are in my cohort. Not fewer people, but percentage wise, right? So So that's a problem. This is actually that idea. So you can see that's contributing to slower growth, not a reduction in real GDP, but a slower growth in real GDP. Right? Capital, why might that be slower? 3.4% is forecast to be 2.1%. Largely that has to do with in the Congressional Budget Office model, the CBO model, comes from higher real interest rates because of bigger budget deficits crowding out, as our model would predict, and from the goods market. So that hasn't happened so much yet. The assumption is that it's still going to, that's still the case. So that's one difference. If they find that there are different things that happen than what the model assumes, then that may be a place where they would have to adjust the model, right, to get a better forecast of what's actually happening. But I think this is probably not far off the mark, personally. So the biggest issue is about potential hours worked. So you can also ask questions about, well, what happens to the labor? So what happens to the labor force participation rate? You could have a smaller group of people in the labor force, right? As demographics, as older people retire and die, smaller cohorts behind. But if a higher fraction of people are working, well, you could still have the same amount of hours of employment. You could also have increases in healthcare, better nutrition, etc. So people live longer and work longer. Right, that could offset that. You could also change immigration policies to increase the number of immigrants, open up for more immigration into the U.S., and that could offset the demographics as well. So those are all things that could affect these projections of potential real GDP. So that's the other way we can ask the question is, so if we wanted to maintain the sort of a longer run, last 70 years, 3.43-ish percentage growth rate of potential real GDP, versus a percentage point lower, let's roughly on just on average, then what would need to be done? And the thing that would need to be done is probably you need to find some way to increase total factor productivity, all right, to offset the decline in potential hours worked. These contributions to the growth of real potential GDP in percentage points, that's like what we have in terms of total factor productivity. Notice this last line down here matches exactly that. But in terms of capital, that's the 0.7 times the percent change in capital, or the 0.3 times, sorry, 0.3 times the percent change in capital, or the 0.7 in percent change in N that we had in our equation that we were just looking at. Okay, so those are the actual projections for the US. I'm going to go back to the what I had up on the screen in terms of the equations, right? So what we're just looking at are these numbers right here, right? And so if this percent change in N is going down, then we need to have something else going up to maintain the same level of real GDP growth. Now, a couple things that aren't in the chapter, right? So this is called the rule of 70. It's an approximation, right? So 70 divided by the growth rate of something is the number of years it takes that thing to double. So if we're talking about real GDP, we're talking about the growth rate of real GDP and how long it takes to double. If the growth rate of real GDP is 3%, right? So this is in percent. So if it's 3, right? So if it's just 3, right? So this is the percent growth rate, right? Then, this is, between 23 and 24%, right? Sorry, years, sorry, to double. If it is 2%, right, which is the projection over the next 10 years by the Congressional Budget Office, then it takes 35 years for real GDP to double. You say, well, okay, that's not such a big deal. All right, so what I'm pointing out here is that small differences in growth rates lead over long periods of time to big differences in real GDP, or anything for that matter. Same is true for money being saved, returns on stocks, in your 401k, etc. Right, so just 1 percentage point difference, 2% versus 3% growth, right, over time matters a lot. Let's take a look. Let's take a quick look at that. Let's say you've got $1,000 today, and we look out over a long period of time. Let's say 100 years, right? And so in one case, 2% growth, another case, 3% growth, right? 2% growth doubles every 35 years, 3% growth doubles every 24 roughly years, right? So let's just call it 25 to make the math really simple. And we'll call this 33 to make their 33 to 34. Whoops, 50. That's what I want, sorry. 75. So what that means, right, if at 3% growth, this is going to, if you had this money in the bank, or if this was real GDP over time, at different points in the future, right? So it's 1,000 today. It's 2,000 in 25 years. It doubles. It doubles again in another 25 years. It doubles again in another 25 years. And it doubles again in another 25 years. So 16,100 years out. So 2%, it doubles every 35 years. Well, let's say it's about 33, just to keep it really easy, so that we can kind of get it to be all match up at 100. Right, so let's say 33 and 66, and then I'm going to get up to 99, 100. So at 33, we're at 2,000 then, right? It doubles, 1,000 to 2,000. At 66, in this case, we're at 4,000. And at 100, we're at 8,000. So if this was an economy, and these were billions of dollars, let's say, or millions of dollars, or billions, so billions of dollars, 1,000 million, right? So, and this was country A and country B. This country's growing at 3%, this country's growing at 2%. This country in 100, they start out equal. They both started out at 1,000. Their real GDP, right? In terms of their real GDP, the standard of living is the same. This is real, so it's not having to do anything with inflation, right? 100 years out, country B is twice as well off as country A. That's just with a 1 percentage point difference in the growth rate. So small differences in growth rates over long periods of time have big impacts, big impacts. So another way to think about this is, and at the beginning of chapter 6, there's actually a table with this, that in the 1900 or so, or maybe 150 years ago, let's say, 1850s, the US was not the top dog in the world in terms of real GDP or real GDP per person. Rather, Australia, Great Britain, etc. And those have flipped. So we have significantly higher real GDP per person than either of those countries today. Because why? Because on average, the US has grown faster, not a lot, maybe a percentage point or so faster than those countries. And so one country can surpass another country over time. They can essentially cross in this way too. It's another way to look at that. So these growth rates matter. Another way to think about this is, if somehow this was like weekly salary, right? This was a weekly salary. In generally, wages go up with real GDP. So this would mean that in 100 years, right, this would be $8,000 every week versus $16,000 every week, twice as much. So another way you can think about it is that at 3% growth, income per person, real GDP per person was doubling about every generation. Actually, more than that, about every 25 years, generation, maybe 25, 30 years. And so the standard of living, our person's standard of living today would be roughly double what parents was, 4 times what the grandparents was at the same age, right? If and this is 2% and 3% overall, not per person, right? So if the population is growing about 1% a year, now we're down to about 1% and 2%. So it takes 70 years to double rather than say 35, right? So in that case, and there's been there's been discussion about this over the last decade, that your generation may be the first in the last 100 years where your children's standard of living may not be any higher or not much higher than yours, whereas it is doubled about every generation in the past. So big difference, big difference. So economic growth matters a lot. We can think about this in another way too. In that Congressional Budget Office publication also talks about the potential labor force productivity. So if we think about, we can also do that in this way. We can think about, let's do it this way. We can do it a couple different ways. But anyway, so let's say output per person in the population. If we just split that up and multiply, so we have n times population. All right. If we just not put numbers, but we actually just use symbols, right? We can break this up in the following way. So what is this? Output per person, which is really what we care about, not just the size of the pizza, but how big a slice we have. All right. That matters. Each person could have a bigger slice, potentially, is what that means. All right. So what does that determine? What is it determined by? This is output per person. This is labor productivity. How productive labor is. What is this? This is the fraction of the population that's in the labor force. That's the labor force participation rate.
Dr. Simpkins, quick question.
Yep.
I thought the labor force participation rate was calculated based upon the people working out of the people who could theoretically work.
Yeah. Sorry. Yep. I was thinking about that as I wrote that. So this is the labor force as a fraction of the population. Right. Sorry. Yep. So demographics plays a role here, right? For example, right? So if you have if demographics means a higher percentage of your population is 65 and older, or 70 and older, or 80 and older, whatever the case might be, then this is going to be decreasing, unless there's a higher percentage of the people who are in the labor force that are, or eligible to be in the labor force that are actually working. So the labor force participation rates matters for that number, but it's underneath that. That's right. That's correct. So what does labor productivity depend on? So we can use the production function for that. K times 0.3, n to the 0.7. If we divide both sides by n, right? Which is labor productivity, y over n, right? So we get y over n is equal to A times K to the 0.3. And then N 0.7 divided by N to the 1 is N to the 0.3, or A times K over N to the 0.3. So what does labor productivity depend on? Depends on things like technology, education, literacy rates, et cetera, things that go into total factor productivity, A, and capital per worker. Not just the total amount of capital, but capital per worker, right? So this is the stuff that goes there. So that matters ultimately for output per person in the economy. This is what we really talk about in terms of the standard of living, right? So why is it then, this is sort of the last point on chapter 6, why is it that the argument is that that total factor productivity, things like technology, are ultimately the keys to standard of living in the economy? Well, capital per worker to the 0.3, right? Let's call it, let's use little k for that. So if we graph k and graph y, right, there are diminishing returns to that. That's what it means to have that 0.3 there, right? So you can keep increasing the capital per worker, but there are diminishing returns at some point. So there's a limit to that growth based on just increasing capital per worker. All right. So in terms of labor productivity, there is a limit to it, right? At the limit, this is 1. If you have everybody in the population working, including babies, right? But the highest that can ever be is 1, right? So there's a limit to that. I mean, it's much lower than 1, right? Because we don't have babies working. We don't have 5-year-olds and 10-year-olds working, right? So it's a lot lower than that, but there's a limit to that. So the question is, can you continue to grow without limit? And the answer is, well, yes, if A is growing, right? So ultimately, it's A that is the key for, in terms of our model, in terms of output per person, in terms of standards of living. That's what Solow won the Nobel Prize for. Just kind of pointing that out, right? What Calvin said was like, well, this seems like just pretty intuitive to me, this chapter, right? So, but that's part of what he won the Nobel Prize for, improving that and using a model to, to do that, and doing the econometrics as well to go with that. But he's done many other things as well. But that was really the key for winning the Nobel Prize. So that's so yeah, ultimately, 2 things. One, if we want standard of living to grow in terms of output per person, right, then technology, infrastructure, education, things that affect A, those are the things that are going to do that. It's partly what is behind the current administration, federal administration, the president, right, Biden administration's push for an infrastructure bill, right, which we'll see whether it happens or not. That is absolutely what's behind that. Right? Also, in the short run, it can create jobs as well, but it's the long run growth of that they're after, right? Every president, Republican or Democrat, doesn't matter, wants to see real GDP grow, and the potential for real GDP per person to grow, right? Because if that's not happening, then standards of living don't grow very quickly. In fact, can stagnate. And once that happens, then anytime anybody gets a bigger slice of the pizza, somebody else gets a smaller slice. So that's the sort of thing that leads to revolutions and coups and civil unrest in countries around the world, typically. So everybody likes, probably it doesn't matter, Republicans, Democrats like to see real GDP growing, and real GDP per person in particular growing faster than population rate. The end part here and so if we go back to this this way of looking at the growth accounting in China, one of the reasons why they did away with the one-child policy was exactly this, right? Because ultimately, unless you can offset that by increases in productivity or total factor productivity in the capital stock, that growth in labor, right, is limited, and that ultimately slows down your growth rate in real GDP. So they doubled that. Now you can have 2 children, right, in China, and but no, people. One of the things about developing countries, as they get more developed and get richer, people tend to have fewer children. So they're actually a little concerned about this issue in China. Population is not growing fast enough to maintain the kind of growth that they would like to see and have seen in the past. So they've got an aging population as well, and even with the 2-child policy, it's not like the population's been taking off in response. Partly because people are working, both parents are working, or et cetera. As in other industrialized countries, that's been the case. So, if government policy is going to be in place, we're seeing an example of that right now, an attempt to use government policy to affect that long-run growth. And it has real implications for standards of living over time, over generations. And that's what we're talking about in the long run here. So any questions about that? We got about, we'll get as far as we can with chapter 7 stuff here in the next 10 minutes or so. We'll pick up with that next week and get into chapter 8 as well, and into 9. But any questions about this? Yeah.
Not directly about what you just spoke about, but how is the size of the opportunity or the output gap varied over time? Has it gotten smaller or larger?
That's the business cycle. So it depends on what's happening, and that's we'll have to wait sort of for chapter 9 for that. It's not there are different ways to answer that. So, and we'll actually look at that in chapter 8. We'll be able to say something about that a little bit, but we've had 2 really pretty significant recessions in the last decade, 2008, 2009, and then last year with COVID, right? So financial shocks in 2008, 2009, and COVID now. So there have been really steep and significant output gaps, right? Actual GDP was a lot less than potential GDP. And the flip side of that is unemployment rates went up significantly. So we've experienced a couple of pretty severe recessions, but they haven't been long recessions. So the other part of the way to answer that is say over time, we had more and longer recessions, that is time away from potential real GDP, than we have in the last 60 years or so, 60, 70 years or so. And part of the reason for that is Keynesian economics and the active role of the federal government, Congress, President, and Federal Reserve in the economy, keeping the actual real GDP closer to potential GDP. So we've had longer expansions in the last 70 years than we did previous to that, and shorter recessions. But business cycles still happen, and sometimes they can be pretty severe, like over the last year, and in 2008, 2009, pretty severe recession as well. Like the Great Recession, was the worst since the Great Depression. So, but it wasn't long. So we came back toward full employment over the next 6, 7, 8 years. Yeah. So that gets in the question of policy. What's the role of government? What's the role of the Federal Reserve in trying to keep the economy at full employment? So we normally think about this today in terms of monetary and fiscal policy, or at least many economists, not all, as what the role of Federal Reserve and the federal government to try and keep the economy as close to full employment as possible, to keep it on its long run path. All right. So there are two things. There are two things that you'd like to do. You'd like to keep real GDP as close to the long run path as possible in that graph that I had to begin with, right? So you'd like the economy to, you'd like it to go like in this straight line if you could, all right? But that's not the reality, right? So maybe there are things you can do to reduce the, right, recessions, right? Because unemployment is high during those times. Probably not to be too far above the trend either, because you get inflation. So typically that you get inflation. That's the worry. That's the question. That's what the model predicts. We didn't see that so much prior to a year ago, even though the economy was probably operating beyond full employment at that point. Unemployment rates were down in 3.5%, 4% range. Typically inflation would start to heat up by then. So business cycle wise, keep inflation low, keep unemployment low, keep the economy growing on its long run path, right? That's the idea, right? So if you're a classical economist, you would say, well, no, the economy is just going to do its thing. You don't need to do anything about it. It will get back to long run growth on its own. But we'll get there when we get to chapter 8 and chapter 9. We'll talk about that. Okay. Go ahead.
I was going to say, my other question was, do certain portions of total factor or certain portions of total factor productivity subject to diminishing marginal returns, like human capital, as an example?
That's an interesting question. That's an interesting question the economists look at. David Romer is a person that's talked about at the end of this chapter. Was an economist who's still working and still doing work in this area, and others. So that is a real question, and I would say the majority view on that is no. But there are these other issues that come about, from externalities, from climate change, for example, right? So can you keep increasing, right? The question really is, can you keep increasing output and output per person without bounds, right? Without bounds. Are there any limits to growth? That's your question ultimately. Because those other parts of it do have limits, do have diminishing returns. And so it's not just education, human capital. So that's an interesting one. I don't think so, but maybe. But then technology. So are there diminishing returns to innovation? Right? That's the other question. Right? I don't think there's any evidence to suggest that. But there are some economists that do. Robert Gordon is an economist who claims, you can go out and look at his you can see his TED Talk. I mean, Robert Gordon's a really good economist. He's an old guy now, but he's a really well-respected economist. And so it's an interesting question about the future. And his argument would be, and he's got a TED Talk on this, that his argument is that there are a number of headwinds coming against the economy, and that we've seen the best of the innovations happen. So he will point to things like the Industrial Revolution, like the steam engine, and then the gas turbine engine, right? And then he will point to electrification as another big one, rural electrification, like not just in the city, like everywhere. And he will point to the standardization of indoor plumbing and water and clean water available everywhere, industrialized countries. And then finally computers, right? And his argument is that, yes, there are diminishing returns and we're at that point. So good luck, folks. So not exactly that, but it's not that things are going to get worse. It's just they aren't going to grow as fast, right? That's the argument. then you have other economists, Brynjolfsson is his name. I forget what his first name is, who, looking out into the future, would say, no, life's going to be great. We're going to increase in productivity, increase living standards, and machines are going to help us have more leisure time. Not clear. Those are two interesting questions, two different views about that. I think most people do not agree with Gordon on that, actually, but that's his view. He has reasons. He has data that to try and that would support that. But I don't know. That's an interesting question. Like that's a good question for the final exam. Yeah, it's a good final exam question. So yeah, those are good questions. So get a PhD and do research on that. That's going to be that's an active area for people doing research in economics today. That question, and will continue to be. So the final exam question is: Can real GDP per person, can standards of living continue to grow without bound? Like that's the question. Right? Depends on K and N and A, and ultimately it depends on, are there diminishing returns to A? Yeah. Not in our not in the model. There's no exponent that's less than 1 in the model, right? So the question is whether the model's right? Question is whether the model's right. All right, so we're gonna pause. We're gonna pause here because I need to go get my shot, and I got to go about 20 minutes to get it. So we're gonna talk about next week. Talking about chapter 7. We're talking about the asset market, and really the idea is we're gonna talk about the market for money market. All right, and ultimately, this diagram is actually not in the chapter. So you can look at also ahead to chapter 9.3. The words of this graph are in chapter 7. And there's a discussion about real money demand, real money supply, the actual money supply divided by the price level, and that's the real interest rate, real money demand, and real money supply on this axis. The point about all of this, where all of chapter 7 goes, is that the Federal Reserve, by changing the real money supply, can change the real interest rate. All right. So the Federal Reserve, through monetary policy, has control over that curve. They can make the money supply whatever they want it to be. They have tools to do that. More importantly, they can make the real interest. They can make the interest rate whatever they want it to be, at least the federal funds rate. And they have a target. That's what they do. And every day they carry out policy to keep that federal funds rate in the target level that they are trying to keep it at. Right now it's close to 0, but they can change that. And as they change that, that has implications for the rest of the economy. Right. So the money market, that's really what it's getting at. That's the place where the price level comes in. We haven't seen the price level at all in the economy. It's the last variable that we're adding, actually. This is the last market we add. So we have the production function. We have the labor market. We have the goods market. Right? Production function and labor market are chapter 3. The goods market is chapter 4 and 5, the international goods market. 6, we have this little, sort of a detour just talking about economic growth, right? And really important, but doesn't. And we have the solo growth model that we could do, right? Which is just an extension basically of the goods market again, right? It really is. And then we have chapter 7, the asset market or money market, the asset market. We'll talk briefly about why they're one and the same. Why we can talk about it as the money market or the asset market, it doesn't matter. And then we bring all that together in chapters 8, and in particular in chapter 9, where we have something called the ISLM FE model, aggregate demand, short-run aggregate supply, and long-run aggregate supply. This IS has to do with the I and the S in desired investment, desired saving in the goods market. That's where that comes from. LM comes from, L is for liquidity, M is for the money supply. So demand and supply in the asset market. All right. Full employment line is determined by the production function and equilibrium in the labor market. So we bring all of these markets together in one diagram. All right. And then aggregate demand, aggregate supply is a further distillation. IS and LM together become aggregate demand, and the full employment line is the same as the long run aggregate supply curve. So we get these diagrams that really represent everything going on at the whole macro level in the economy, but they come from all of the other markets underneath. And so we can trace back all the impacts on employment and the real interest rate, on saving, on investment, and unemployment rate once we get there. So that's where this is headed. So chapter 7, that's the last piece of that model. It's pretty straightforward. We don't need to spend a ton of time on that, actually. Chapter 8 talks about the business cycle behavior in the economy. Chapter 9 is bringing it all together to create the model to explain the business cycle behavior in the economy. So that's where we're headed. So we'll do chapter 7. We'll take some time. We'll get into chapter 8. We'll probably get into chapter 9 as well next week. Okay. So it's a wrap from me right now. I need to head out. So I'll stop sharing and I'll just say, I'll make the movie, I was going to say, the video available over the next couple of days, hopefully, and then we'll move on to the rest of this. We'll have a couple more weeks. We can spend another time period following just on chapter 9 and sort of wrap up anything that we need to do. So we'll spend the next 2 weeks doing the rest of this. Okay.
Thank you, Dr. Simpkins.
All right. Have a good rest of the day. Calvin, I saw that you made an appointment, so that's great. It's fine. No worries. And Friday, I think, right? As I saw. Yep. So, all right. I'll see you on Friday. Thank you for coming, Tanisha.